in English which is called mathphobia or fear from mathematics. Now let us be honest, we all suffer from mathphobia. We are all not very comfortable when it comes to assessment, examinations, or when we are talking and studying mathematics for a very long time. We have a kind of a not a good feeling factor. It is not something which we really enjoy. What I'm going to do in this particular video is that I'm going to give you 10 very practical tips, tricks and techniques, and I can promise you if you follow them, then you will succeed in your career in mathematics. You're going to enjoy mathematics. There will be no fear or anxiety when it comes to assessments or examinations, and finally you're going to fall in love with this subject. But yes, please do follow them rigorously. My name is Shaunak and you're watching this video on my channel Physics for Students, and I heartily welcome you to watch this video. First of all, we need to understand, is it a fear for mathematics or is it an anxiety for mathematics? Now come on, you might be thinking, am I teaching you something literary, the difference between these two words? But no, this is something very, very important. This is required. Why I will tell you. See, fear is something which has got a definite purpose. Now the fear is that if I fall down the hill, I will break my head. There's a fear of bankruptcy. There's a fear of, more precise, anxiety is something which is called anticipation of experience. Now you might be wondering why I am telling you. See, the reason is that whenever there is an examination which is coming, or whenever we are seeing certain symbols in mathematics and we say, oh no, we cannot do it, that means there is nothing which is definite, but this is something which is not something definite. That means there is an anticipation of experience that we might face an error, we might fail, we might not be able to do the equations. What will happen if I fail in the examination? What is that those things which I really don't know comes in the assessment and then I will fail. My teachers will scold. I will get a very bad marks in assessment. So first of all, what you need to understand is that it is not called a fear in mathematics. It is an anxiety in mathematics. I hope I can make things clear. Fear is something totally different which has got a definite objective. And we don't have any definite objective, right? Because it is all unknown. Oh, I don't know the symbols. Oh, trigonometry, what it is all about. What are the problems? I really don't know what will happen. What are the questions? I really don't know whether I will be able to clear. That means whether it will come, whether I will know. That means there is an anticipation. Try to understand. Anticipation means that it might happen, it might not happen. That means it is not clear. It would have been clear a fear. I would have made a different video right on this. So first of all, it is an anxiety of mathematics, not a fear of mathematics. Come on. Anxiety means something which we have not seen, we have not experienced, but there is something which keeps on haunting our mind, that it might come. What will happen if mathematics is difficult, if I don't know the symbols? Are you getting my point? So it is basically an anxiety of mathematics, not a fear of mathematics. Fear is something definite and we really don't have anything definite, and that is why we keep on thinking and there is an anticipation that this will happen, this will not. I hope I can make things clear. This is important. So from our vocabulary today, let us remove that there is a fear of mathematics. No, we have an anxiety of mathematics. Now, when we talk of anxiety, as I told, fear comes from a definite factor. Anxiety comes from something which is not very clear. And you know why it comes, that because of something which is not clear. It is because you don't have an objective. Anxiety happens due to no clear definite reason. There is nothing which is definite, clear in front of you. And the reason is this: you do not know, or you do not have anything definite for mathematics. That means you really don't know, why should I do mathematics? So anxiety is basically due to unknown reasons, anticipation, and your anxiety of mathematics is coming for one particular reason, because you don't have a definite objective, a definite reason, why should I do mathematics? After removing the word fear from our vocabulary, we know that we are suffering from a little bit of anxiety of mathematics. To overcome the anxiety of mathematics, we need to have a constructive, definite objective. That objective is called, why should I do mathematics? Now, right here on your screen, I have given 6 definite objectives or reasons, you can say, why should I do mathematics? Problem solving skills, innovation and creativity, logic and reasoning, developing transferable skills, learning to think, not memorize, to understand the beauty of nature. Okay. What do we mean by problem solving skills? Now let us move out of mathematics. Okay, we are not talking of mathematics anymore. Let us say, for example, we are talking about geography, let us say history, or maybe English literature, or maybe any personal problem that you are encountering right now in your family. It can be finance, it can be relationship, anything. But if you have got a kind of a mathematical brain, I would say you can solve and have a problem solving ability. And as I told you, that let us forget that we are a math grad or MSc, physics, mathematics, anything. We are just something which we are not into mathematics. So number one, problem solving skills enables you to solve any kind of a problem, be it history, geography, finance, relationship, problems with personal issues, anything. So that is point number one, which is called a problem solving ability, an ability which will make you solve any kind of a problem. Coming to the second part, obviously when you can solve a problem, then you have a new innovation. If you see my earlier video, which is right, I have given in the I button, that how you can improve your mathematical skills. I have told that when you work in groups or in you create a study group, automatically you have different kind of innovation facilities. Why? Because we are interacting with many friends. So innovation and creativity is one, and the second part, that if you have a problem solving, if you solve a problem, definitely you innovate a new way. Third is logic and reasoning, which is quite obvious. If you have a mathematical outlook, then you have a logic and reasoning. Fourth is, which is called developing transferable skills. Now, what are transferable skills? For example, communication, leadership, motivation, coordination, these are transferable skills. What do we mean by transferable skills? Transferable skills means those which can be transferred to many other departments. So you are an engineer, you need a communication, leadership, motivation, team building. If you are a chartered accountant, you need the same. If you go to become a successful salesman, you know those things. So mathematics enables to transfer those skills into separate department. You have got that kind of an outlook. Learning to think, not to memorize. Now this is something important. I have seen it with my daughter. She is very young, but talking to you, the grads and the postgraduates, most of the teachers, although I being a teacher, they will tell you that, okay, you memorize the theorem, you memorize the equation, you memorize the formula and solve the problem. That is not. If you're doing with real analysis or Calc 1 and Calc 2, you will see that there are a lot of things that you need to derive. That means you really are thinking on a particular problem, you're not memorizing. And I can tell you, any subject, not only mathematics, you can go into physics, into geography, history, other than the birth dates, etc. It is all about thinking, thinking and thinking. Mathematics enables you to think on a problem more and more rather than memorize and memorize. Lastly, to understand the beauty of nature. And right now I'm in my study room, so I was right on the rooftop, so you know the beautiful sky, the beautiful leaves, the plants, the stars, the rivers, all of those have got a beauty of nature. And as have been pointed in this particular quotation by Carl Gauss, we cannot identify the nature until we have a mathematical eye. So all the beauty of nature, starting from the rivers, from the beautiful flowers and everything, you see that in topology also we deal with structures, beautiful structure, beautiful shapes. Why? Because it is all mathematics. Until we understand mathematics, we won't be able to understand the beauty of nature. Right on your screen, you will see I have shown certain tie knots which we tie, right? Windsor, Half Windsor, Four in Hand, Nicky, Eldridge, Atlantic, right? Now, you might be thinking, am I teaching you how to tie a knot? No. What I'm trying to tell you is that these, beautiful tie knots, these shapes are also carrying a lot of intricate mathematical details. So this is an example that the beautiful tie knots, the underlying structures are also in mathematics. Now this is another wonderful book which I can show you on the screen, the shoelace book. Now this is more than, if you read this book, this is more than shoelaces, tying shoelaces, but this is something which shows that how you can improve your mathematical ability. So you see on the screen, I have shown double back, lattice, hidden knot, sawtooth. These are different structures in which you can tie up your shoelaces. So that means tying up a shoelace is also very intricate and carries a lot of mathematical structures. Here on your screen you can see the logo of Twitter. You can see, we all know the logo of Twitter, that bird. But do you know that this logo is being designed using a golden ratio? Now, I'm not going to explain you what is a golden ratio. Possibly you all know it's from our school days. But I just wanted to show you that even the structures of Twitter, not only Twitter, Pepsi and other logos are being done using mathematics. So this also shows you why mathematics is important. Now right on your screen I will show you a very simple equation. A plus A equals to 2 times A. Just for a school going boy or a girl can understand. That means 2 plus 2 equals to 4, 2 times 2 equals to 4, right? 3 plus 3 equals to 6 and 2 times 3 equals to 6. What is important is this, you see on the left hand side it is a sum, 2 plus 2. And on the right hand side the same result is given through multiplication. 2 times 3 equals to 6. So what I'm trying to tell you is that the multiplication also has an underlying beauty. It has underlying language, and that is why it is called a metaphor, that whatever is on the left hand side, the summation, we are seeing the same thing as a multiplication on the right hand side. What does it mean? It means that what you are saying and what I am saying, there is a difference in perspective. Why there is a difference? It is because of mathematics. It is because mathematics has enabled us to see that what you see and what I see, there is a perspective difference. I'm not saying that they are different. They are obviously equal because 2 plus 2 equal be 2 times 3. But there is a perspective difference which is evident in this equation. This also shows that mathematics is the underlying structures. So this part of the video shows that why you should do mathematics: to enjoy the beauty of nature, to improve your personal finance or any kind of a problem solving ability, to have greater innovation, to have a logical reasoning, and to think and see things in a different perspective. Okay, so before we start into the techniques and the tricks, I will tell you, let us assume. Okay, now what do I mean by let us assume? Right on your screen you will see, first of all you have to understand that everybody struggles with mathematics. Now come on, you cannot come and tell me that I am brilliant, I do great. You might be brilliant, you might be great, I don't mind. But the fact is that everybody struggles with mathematics. Point number 2, some people understand mathematics faster. I have seen in my school and my college days, boy and girls just sitting by my side, they do mathematics so fast. They do calculations pretty faster. So some people will understand mathematics faster, that is a fact. Some people do calculations faster, that is also a fact. And some people can solve problems earlier. If you see in the college, otherwise you will see that there are boys and girls who can do mathematics much faster than you. At least I have seen that. I'm not a brilliant guy in mathematics. And you will see that people can solve and do calculations much faster. Now, why I am trying to tell you that let us assume and let us do things much faster, the reason behind is that let us not get frustrated. There will be people who do mathematics faster. There will be people who can do calculation faster. There will be people who can do problem faster. That is okay. That is absolutely fine. We should not get frustrated, I can tell you, but in spite of that, you will see that you can do mathematics, and that is the whole purpose of this video, to help you, enable you, motivate you, to tell you that yes, you can do mathematics. Right. So assumption of those things, and you must understand that everybody struggles with mathematics. There are people who do things faster, no problem. Let us not draw a comparison between those people with us. Let us try to improve our skills, right? But there are people who do things faster. For example, Terence Tao. Now this guy completed PhD at 21 years old. When he was 21 years, he completed his PhD in mathematics. Brilliant. I'm to say, what else would you do? Kurt Gödel completed his PhD in mathematics and philosophy at the age of 23. Now, I mean, so what else you can do with Gödel and Terence Tao and people like that? You know, Isaac Newton, for example, brilliant. I mean to say, let us not compare with them. Let us assume that they are there, they're respected people, and they can do mathematics faster. That does not mean that you cannot do it. So, assuming those things will remove the frustration in your mind. Mathematics, it hurts. Oh, no. So this is a kind of a feeling which will eventually come. It is true for everyone. This is the problem number one. Mathematics, it hurts. Now, the reason I will tell you why it hurts is that most of us are taught as a language of symbols. Mathematics is a language of symbols. Here on your screen, you see I have given a lot of symbols, and this is exactly what we face when we are learning mathematics or when we are going ahead with mathematics as a career. Now, I want to move away from mathematics, thinking mathematics as a symbol, but rather than give you certain different things. Look at your screen here. Can you see, can you understand those symbols? Now, I know that there are people who know the symbols other than that. Now, look into this screen, this for illustration also. Now you see, it really doesn't carry any meaning. What are those symbols? What are those meaning? That means, you see, it is not only mathematics. It means that any kind of an unknown symbols, looks like Greek hieroglyphs, etc., are a kind of a problem. It creates a kind of, no, we don't want to do with those things. Now, if I assign with you this, right on your screen, you see, this is A, B, T, and these are 2, 3, and 5. Just to tell you, these are Arabic words and numbers. I learnt it in my early college days at Ramakrishna Mission, so I know those things. So immediately when I assign you with some values, A, B, T, 2, 3, 5, you can say, okay, fine, you give me more consonants and you can give me more, more vowels, and I can make out my name. My name is Shaunak, his name is Bob, this is water, this is river, all those things. What does that mean is that if we know the meaning of those symbols, then we can construct a language, we can construct a sentence, and mathematics is basically a language. So I wanted to show you more on this. Look into your screen. What are those things? Now, you know these are symbols of music, but do you know what does those mean? Really carries no meaning. Now you see, this one means 4 beats, this one means 2 beats, then there is a 1 beat, 3/4 of a beat, 6 beat, 3 beats. So now I am assigning the meaning of those hieroglyphics or those symbols, right? And you can understand the meaning, right? So what I'm trying to tell you is that all those advanced structures or symbols in mathematics comes out of only 4 basic operations: addition, multiplication, subtraction, and division. Further, all those are advancement in order to make life easy, not to make life difficult. So these symbols actually create a kind of a problem. So what I would first request is that whenever you're encountering this kind of a symbol or problems in mathematics at an early level, try to understand that these symbols are signs to communicate, right? So for example, if you're dealing with special education children, we deal them with signs because they cannot hear, they cannot see, or possibly they cannot talk, right? So the way you communicate to your parents, to your girlfriend, to your boyfriend, to your anybody, these are ways of communicating. Because we cannot say 7 times 3 equals to 21. We have to write a huge number of words, right? So we put 7 cross 3 equals to 21. That's it. So it is something which is made, which is done in order to make life easy, not to make life difficult. So that is the essence. The first problem which we encountered is that mathematics hurts. It hurts only because of symbols, and once we understand those symbols, we will be able to do anything. Can we understand mathematics? Now, this is a very common question which is common to every school student, school-going grads or undergrads. Can we understand mathematics? I would like to show you this. Mathematics is a language. Okay, it is just a language. The way I am communicating to you over the video, you are communicating to many other people. I will just show you a very simple example. See on your screen what I have written. You ask this to a kindergarten student. What is 1 apple plus 2 apple? Sorry, 1 apple plus 1 apple. It gives 2 apples, quite evident. Now see that I am not talking of addition. I am talking of taking mathematics as a language. Point number 2. What is 1 pencil plus 1 pencil? It is 2 pencils. As simple as that. So if 1 apple plus 1 apple yields to 2 apples, and if 1 pencil plus 1 pencil gives to 2 pencils, that means we are dealing with mathematics as a language, not as something as a symbol. Now you ask the same question to a kid that what is 1/3 plus 1/3? Do not look into the fraction which is showing on the screen. Try to understand it as a language. That kid will say 2/3. What is 7x squared plus 2x squared? It will be 9x squared. That means that kindergarten kid does not need to learn exponential or fractions. If 1 apple plus 1 apple give 2 apples, obviously 1/3 plus 1/3 would give you 2/3. That means that if we can approach mathematics as a language, it becomes easy. It solves problem. You will see, I will show you on the screen, most of the kids do not know this meaning. 7 cross 3 means 7 times 3, which means 3 7 times, which means 3 plus 3 plus 3 plus 3 plus 3 plus 3. How many times? 7 times. So instead of doing a multiplication, if we teach them, hey kid, come on, 7 cross 3 means 7 times 3 or 3 7 times, and we have to write 3 plus 3 plus 3 plus 3 7 times. That because we are using just a symbol cross, and that eliminates all those time and effort. So what I'm trying to tell you in this particular part of the video is that let us understand mathematics as a language. So we cannot understand mathematics because we consider it to be something very difficult, something which carries symbols. No, symbols are made so that we can squeeze the number of lines which we otherwise write in English. So mathematics is a language. If we learn that language, we are able to communicate just in the same way we can communicate if we know Spanish, German, Italian, French or English. Okay, so third problem is that I do not see any use in mathematics. I would say that is true because we are taught, as I told you, mathematics as a symbol, and we really don't have anything which we can see which can be used in mathematics. What I would suggest to you is that let us learn to solve problems and see the practical usage of mathematics. I'm very, very sorry to tell you this today over video, but most of the teachers, I also being a teacher, do not show the practical usage of mathematics. Just mug up the problems, do the problems, come up, fine, score a good score in the assessment, examination, done. But mathematics has got a lot of, it is a tool, let us understand. It is just like a wrench, right? You tighten the screw or you loosen up the bolt. So let us learn to solve practical problems, and once we understand the practical problems, then only we can understand and we can get out of this problem. I do not see any use in mathematics. Now I have shown you this right on the screen of yours. You will see this is the application of dot product on a solar panel. Now what is solar panel? It takes the energy of the sun and it uses that, right? So this is actually explained in my earlier video on dot product. It is there in my linear algebra playlist. If you see, I have shown that how dot product can be used in practical usage. That means if the angles of the dot product are being changed, the solar panel adjusts accordingly to the sun and we get more energy. Second one, as you can see, computer games immensely improved in terms of dot product. Why? Because computer games creates a kind of a field, and say for example I am firing or I am chasing after a monster. The monster, how far the monster is, right? Whether it will get hold of me, whether I will fire a gun, whether it will hide. So all these mapping, how far it is chasing the monster, whether the monster will come and check on me, these are being done using dot product. That means the angle of the dot product will eventually determine the proximity of the location where the player is and where the opponent is. Practical usage of mathematics. Third part, I have dealt in details, but just to sum up very slow in short, that plagiarism plagiarism of documents, research papers are also being used using vector analysis of mathematics. So I just wanted to tell you that mathematics, because you cannot see the usage, that is the problem. Please try to understand that mathematics, right from the days of the Greek and Indian Hindu culture and those early ages, this has been created to solve problems, not to make your life difficult. It is not to make your life difficult. This has been made in order to solve problems. This has been made in order to make your life easy. So mathematics is a tool which is used to solve problems. We unfortunately do not understand that mathematics is used as a tool. So because you do not see the use in mathematics, maybe you are not being taught or you are not having that perspective. Please look into mathematics as something which is a problem solving tool. And that is the second problem which you will overcome, that yes, I can really see the use of mathematics. The next problem which most of us encounter, and maybe that is also a reason of getting frustrated, is that we make a lot of problems in solving equations. Now I would say that is okay. That is absolutely fine. You should understand that making errors or making problems is not something which will destroy your career in mathematics. Let me give you certain examples. You know about Albert Einstein, one of the greatest mathematician and physicists. Now he is one of the greatest, he has made a great error which is called a cosmological constant. I would like to show you, I just got, let me see that I can show you this book. This book is called Brilliant Blunders, and it speaks about the brilliant mistakes which people have done. And it covers these chapters, mistakes and blunders, right? The origin, that is of Charles Darwin. Then you have got how old is the earth. Then we have got interpreter of life, the Big Bang. So it actually covers a lot of mistakes which people have done. I particularly kept this book in order to show you that these are called brilliant blunders, mistakes which people have made, mistakes which Isaac Newton have made, maybe Albert Einstein have made, maybe Charles Darwin has made. Great mathematicians and physicists, they have done mistakes, and that is why I kept this book, just to show you that it is called Brilliant Blunders. People will make mistakes, people will suffer from mistakes, and that is absolutely okay. I mean to say, there is no problem in making mistakes. There is absolutely, you should not feel shy that it is you are making a mistake. Every single individual, every great people has done a mistake. So what? I mean to say, if you make a mistake, what will happen? You will fail in the assessment, right? But that doesn't stop your life. That doesn't end the life. That doesn't terminate your career in mathematics. Come on. So I would say that you should accept this idea that mistakes are okay. We all make mistakes. We learn from the mistakes. Mistakes are the pillars of success, we can say. And this book, why I showed you, it's a brilliant book. I have read it. If you want, you can purchase this book. This is by I think by Mario Livio, and it's called Brilliant Blunders. And possibly you will get motivated once you learn that yes, these people also make mistakes. So it is fine to make a mistake. It requires a lot of time. No problem. We understand. Everyone understands that it requires a lot of time. So I mean to say, you can consider this just like as a bodybuilding technique, right? So even bodybuilding takes a lot of time. I can give you a very practical and a personal example. There was a time when I was suffering from huge amount of belly fat. Okay, and it won't happen that if you make 20 push-ups or 100 crunches in a day and don't take food for one day, your belly fat or your fat will be reduced. It never happens. You will fall sick. Same way, if you think that one day I do mathematics and I will be brilliant, it is not at all possible. Not only for mathematics, it's take for music, for geography, for bodybuilding, for athlete. Everything requires a huge amount of practice, and eventually, yes, it will require a lot of time, because you cannot make up a body within 10 days or 6 months or 1 year. You require time. Similarly, mathematics is like 1, 1, 1, 1. It is building up on the bases, and these bases comes only when you practice, and you have to give a lot of time. So what I would suggest you is that do every day a little bit of mathematics. I'm not saying that you do 8 hours a day every day. This is humanly not possible. You get frustrated. But do a little bit of mathematics every single day and make it as a habit. I mean to say, let us not miss on a single day. We do 10 minutes, 15 minutes of mathematics or practice on linear algebra or calculus. If you grow up the ladder, you get more time. That's fine. But you do a little bit of mathematics, half an hour, 45 minutes, but do it regularly. And that would help you, just like bodybuilding. Exercise every day, do mathematics every day, little bit of mathematics every day rather than lot of mathematics on a single day. It would help you. So yes, it requires a lot of time. You have to give that time. You need to segregate and strategize the time so that you are concentrating on all other studies along with that mathematics. Do a little bit of mathematics, but make it as a habit of doing it every day. Coming to the next problem is called I am unable to concentrate while studying. Again, I would say this is okay. This is common to every single person. Now, why you are unable to concentrate? Don't take me wrong, because you are too much digitally connected. Okay, so what I would say is this, what you can see on your screen: digitally disconnect. Shut out your mobile, WhatsApp, Instagram, Facebook, notifications, telephone calls, and just do the next one which you can see on the screen. Focus, focus, and focus. I mean to say, there are people who have got a longer span of focus, maybe 45 minutes, 1 hour or so. They can focus for a long time. But if you don't have that kind of a focus span, you can focus for 20 minutes, you can focus for 25 minutes, that's it. But focus, and remember, hold it. You remember that if you put a magnifying glass, right, and the sun rays are streaming in, right, and if you focus it, eventually a cloth or a piece of your paper will eventually burn, right? Why it is happening? Because you're focusing the sun ray. And also, if you keep on moving the magnifying glass here and there, it is never going to happen. Why? Because you have to hold that focus. You see, I was listening to a few of the lectures of Swami Sarvapriyananda and others. You will find that most of them, the student, if you go to Harvard or Cambridge, I don't know whether you talk to those brilliant people, you will see the only difference that makes from other students is that they can focus. Let us keep apart those senior people or the monks, but if you talk of the young people also, for 45 minutes when they are studying, they are digitally disconnected. They have put off their WhatsApp messages, no telephone calls, short span of time, 25 minutes, intense study. After 25 minutes, you can give a 10-12 minutes break and again go back. So I understand talking over video, it might be very easy, but that is what is required. You need to focus constantly and hold the focus and digitally disconnect. You remember those young days when the little children used to say, they used to put their hands over here and you have to do this. Why? Because the sounds of the parents, the sound of the television, etc. coming as a distraction. So they used to put their fingers within their ears and they used to study. Why? Focus. That is called focus. You have to focus it, you have to hold it, and you have to disconnect digitally yourself and just do this study. And I can believe you, if you follow this, you are going to concentrate not only in mathematics, but in every sphere of your study. Okay, but still I am unable to find an answer. That is a big problem. Now, you are facing a problem in mathematics. For hours and hours you are struggling, you are unable to find an answer. You are writing to your professor, they are replying, still you are unable to find the answer. You are again sitting with the same problem, you are still unable to find the answer. You are going to Google, writing it in different forums, still unable to find an answer. So what I would suggest is this, which you can see on your screen. Sometimes you have to let it go. Sometimes you have to let it go. Go out, go for a walk. I can tell you, long walk helps you. If you've got a garden or an orchard, go for a long walk. Have a cup of coffee. Talk with your family people or your friends. Have some food. Take a kind of a sleep or take a kind of a nap. Take a break out of those things. I can tell you, this really works. It really helps you out. Breaks are important. Now, you will see there are many professors and teachers who are constantly telling, no, study, focus. Yes, that is important. But most important is that take a break, take a nap, take a sleep. You know, when you go into the gym, right, you exercise your muscles from Monday to Friday, right? And they call it rest days. So what are rest days? Rest days are those when you're sleeping, you're going out with your party, with your friends, relatives, and that is the time when you're relaxing your muscles and you make your muscles grow. Your muscles really don't grow when you're pumping up, right? Your muscles grow when you're relaxing. Similarly, when you're relaxing in terms of mathematical problems, you are still thinking in your subconscious mind. I mean to say, for example, you're going up for a long walk and you're stuck up with a Calc 3 problem or a differential geometry problem. Your subconscious mind is thinking constantly. So that thinking will eventually give you a big problem. You remember Archimedes, who was relaxing on a bathtub, and suddenly he got the buoyancy principle. Eureka, I got the answer. Now he was thinking about the problem, but he was relaxing on a bathtub. So it was the relaxation time which evolves the breast. I remember Stephen Hawking also. Now he was possibly during that time, possibly his son was born or something. Maybe whatever, that he was relaxing and he was thinking of the problem. And then suddenly that Hawking radiation, that black holes can also radiate energy, it immediately struck his mind. Professor Andrew Wiles, a great person. You know, if you see his interview, he thought that at some point of time he got stuck up with this Fearofmaths last problem and modular forms. He went for a long walk. I can tell you, walk really helps you out. Have a cup of coffee, relax, and you will be able to get hold of this answer. So remember that breaks are important. Breaks really relaxes your muscles and neurons and your thinking capacity, and it was during that time the brilliant and the most brilliant ideas come up. So relaxation and break is a must. Do relax, do take a break whenever you're feeling that you're overdone, you're unable to understand, you're too feeling claustrophobic with the equation of mathematics. Do take a break. I am getting confused. This really happens. You're struggling over a mathematical problem too long, constantly one by one, and you are getting stuck up and you are saying that I am getting confused. I would suggest you, which I have not done in my college or university days, this is on your screen, create and work in study groups. Now, if you work in groups, there are many things which happen. First of all, you are relaxing, right? You are talking of mathematical or physics problem, that is okay, but you're talking with your friends, you're interacting, again, you're relaxing, and that is how, through relaxation, the best ideas do come. Remember, I am talking not of WhatsApp group. I am talking of physical groups when you're going to a college or somebody, friend's house with 2, 3, 5 boys and girls, and you have created a group through which you can study. So one is that you're relaxing, you're interacting, which eventually relaxes your muscles and neurons and which helps you out. Second thing which comes is that there's a famous saying which is called, until you teach, you cannot preach. That means, for example, so-and-so of your, one friend of yours and come and tells you, hey, come on Bob, can you tell me a little bit how you solve this integration or differential problem, right? And you explain that to him. Now what happens is that when you're trying to explain that, suddenly you start, oh no, this is not the way I should approach, or rather I'm unable to explain that to that person. You go back to your home, you go back to your mathematics and you restudy. So the best part is that when you're teaching, you're explaining a lot of things, lot of concepts will become clear. I will tell you a very personal example. I made this YouTube channel around about 1.5 years back. The basic idea is to test myself that do I teach or can I teach well? How much do I know calculus, differential geometry, topology, general theory of relativity, curvature, philosophy, analysis, whatever. Now today this channel, I have got so many great subscribers. I'm really thankful to you. that you have helped me to grow, you have helped this channel to grow. So I'm immensely thankful to all of you who have helped me. Anyway, that's a different issue. So what I'm trying to tell is that if you teach, you can learn a lot of things. Once you teach, once you try explaining things, it will become much clearer. And that can only happen. Now come on, you cannot call your parents from that room and tell, hey, come on dad, I'm going to explain you what is complex analysis, or what is an isosceles triangle, or what are things like that. They're not going to listen, or maybe they will listen. But it is better that you create groups, friends of similar interest. Now I will tell you, I don't know whether it is here in India or not, there's something which is called buddy teaching, peer teaching, which we do. Right, so buddy teaching is, for example, I'm here, Shaunak, and I don't know much about algebra or trigonometry. My teacher assigns another person, a boy or a girl, who knows a little bit better than me, but he's a buddy, or she's a buddy, a friend. Then we create a group, right, and we try to solve a problem which our teacher has given. And because I'm weak, she or he will help me. She or he will help me in order to understand and solve that problem. That is called peer teaching, buddy teaching. Because a student is not always very clear and open to a teacher. He or she might feel shy, might feel, oh, if I go to the teacher will again scold me, right? So if I explain to my friend immediately sitting next to me, what happens is that the buddy teaching or the experience improves. I learn a lot, she learns a lot. So that is point number 2, that you should include group teaching where you can interact, teach with each other, which improves a lot of mathematical knowledge. Third and the last point which I would like to tell you is that it improves a way of innovation. So I am thinking to solve a mathematical problem in this direction. My friend is teaching in this direction. He says, hey, come on Shaunak, if you do the angles and drop a perpendicular, you can find out the geometrical problem easily. And then I think, oh, I never really thought about that. Because I was thinking in this direction, my friend has shown me in this direction. That means the same problem being approached in 2 different directions. I hope I'm being able to make things clear. So this approach and this approach, maybe both of them are correct, but these are 2 different approaches, 2 different perspectives, 2 different ways to get things easier. And that is only going to happen when we create a group. So the basic mantra of this part of the video is that you should interact with people so that interaction helps you to relax. You should start teaching what you have learned to your friends so that your concept is clear. And third is that the perspective and the difference increases and gives a wider and a huge way of solving or approaching mathematical problems. I feel bored while doing mathematics. Now this is also very common, right? Actually what happens is that you start feeling boring when you are not fresh enough. You are not relaxed and when you are really feeling very tired. So my first request or an advice would be for you that please do mathematics when you have got a fresh mind, when you are mentally fresh, when you are physically fresh, when you are not feeling tired. I mean to say, when you're coming back from universities or colleges and you feel that, oh, I again have to sit down with trigonometric or algebra problems, okay, or maybe onto higher level. So, your eyes are tired, your muscles are tired, you are physically tired, you really know, come on, again I have to sit with so many problems. I really don't want to do that. So I would say the best time for people, I mean to say for me at least, is to do mathematics in the early hours of the morning. Wake up around the early morning, go for a jogging or for a little bit of a gym or exercise, and then come back, have a cup of coffee with cookies, etc. and sit down with mathematics. The reason is that because mathematics is something which builds up on certain levels, builds up on certain bases, and it requires a kind of a full attention and improves the analytical brain. It won't happen when you're very tired. Now what is fresh for me in the morning might be fresh for you in the afternoon or for somebody in the evening or late night. Not a problem. But the basic idea of is that do the mathematics or do the problems when you are really fresh. I mean to say mentally you are fresh, physically you are fresh. Sit down with those set of problems. Attack those problems which are difficult, not with those which are easy. because difficult problems or challenging problems will require time, and eventually your muscles will dry up, your muscles will feel a little bit fatigued. So start at an early morning or whenever you feel fresh like, and attack those problems which are very difficult, or you think those to be challenging. Last and the final point, can I really do mathematics? Now for me the answer is a big yes, you can do mathematics. I mean to say, for example, I'm not saying it to the teachers or anybody, but we are generally taught in this direction that no, you cannot do mathematics. How can you do mathematics? You have done so bad in class 9 and 10. How can you do mathematics? You don't even do a calculation mentally. You need to be hardwired in order to have mathematics. Your brain has to be something kind of a superhuman being with a different kind of a bent of a mind to do mathematics. I would say no, it is absolutely wrong. I've seen people, I've seen scholars, I've seen brilliant guys and men and women who can do mathematics, but eventually they have not done so well during their school days. I can tell you they have done mathematics brilliantly. I can tell you they have done mathematics with such a frame of mind which is absolutely brilliant. You won't be able to imagine. The thing is that we are taught in that way. We are brought up in that way. There's a social taboo. I'm sorry to tell, but there is a social taboo. There is a problem that we cannot do mathematics. Mathematics is not for everyone. I can tell you mathematics is for everyone. You can do mathematics, you can do brilliant mathematics. Only thing is that you have to just follow those techniques rigorously and religiously. I can tell you when I was in my young days at Ramakrishna Mission, so what used to happen is that when we talk of focusing on something, there is something which we call the monks. You wearing a kind of a robe, you kind of a crimson robe, and they come down and they talk. Now, what do we mean by monks? In general, you mean by monks that those who are outside the world, those who have left their family, friends, father and mother, and doing religious practice, they are the monks. But they are not. I will tell you, monks are those who concentrate and focus on a particular problem. If you focus on linear algebra, if you focus on trigonometry, if you focus on real analysis, eventually, so intense is your focus, you will eventually lose out everything. You won't interact with people. I told you, digitally disconnect. You won't interact with people. You won't attend to phone calls. You won't reply to your messages. So what is happening? Slowly you are moving away and away and away from mathematics. That is what is called a monk. That is what is called a monk, or a complete dedication to the duty. And that is how you become a great mathematician or a great physicist or anybody who is successful in the industry. So answering to the last question, can I really do mathematics? Yes, you can do mathematics. Yes, you can do great mathematics. You can build up your career. You can do anything that you want, provided you believe in yourself, provided you follow the tips and techniques, provided you focus and you digitally disconnect, and provided that you firmly believe in yourself that mathematics is a language, nothing more than that. Okay, so that brings us to the end of this video. To be very honest, I was really very emotional and passionate to make up this video, because a lot of students, a lot of subscribers have earlier also told me that why don't I make a video on how we can overcome the fear of mathematics. First of all, we should understand there is no fear. This is something called anxiety, and anxiety is something which happens when we really don't know about the experience and we really fear from those experiences. So first of all, we already removed the concept of what is called fear. Fear, it is not fear, it is something which is called anxiety or an anticipation of experience. Second thing is that why should I do mathematics? I clearly laid out those points. It improves the analytical and problem solving skills, logical reasoning, innovation, a lot of other things, and most importantly, enjoy the beauty of nature. I also showed you certain examples of designing Twitter and other logos which are done to mathematics. I also told you that you need to assume certain things. Some people will do mathematics, calculations and other things faster. Let us not feel frustrated on that. Mathematics is a language of symbols, but most importantly, mathematics is also a language. And it is not only the symbols that make you a little bit feel weird, but it is any kind of a symbol, be it Spanish, Japanese, German or Hebrew. Anything which you don't know will come as an apprehension, will come as an anxiety. Next time, what I told you is that mathematics is a language. We need to understand it in a language. I just told you 7 cross 3 means 7 times 3 or 3 written 7 times, but we are not taught in that. That is the problem. We also find out that we need to find out mathematics to solve real life problems. Mistakes in equations are okay. We should not be afraid. Everybody makes mistakes. I showed you the book Brilliant Blunders where you can find out the mistakes. It is also that it requires a lot of time. Yes, because it is just like bodybuilding. You cannot make up your body in just a few days of time. Also, you need to concentrate while studying, and that can be done when you digitally disconnect with each other. You need to focus and most importantly hold the focus. Breaks are important, very very important that you take a break, you take a nap, you take a long walk, because during that time your brain still works and you can find out those problems. Interact and study with groups, very important, so that when you teach you understand things better. Also, when you're feeling bored, a little bit down in mathematics, do mathematics at the right point of time. And yes, I can do mathematics. Can I really do mathematics? Yes, I can do mathematics. Only thing is that you need to focus and focus. I will just end this video with one very famous quotation, if I am quoting it right, from Bhagavad Gita, where Lord Krishna was preaching to Arjuna about concentrating and doing this and that. And Arjuna was telling, oh Lord Krishna, isn't it very difficult to concentrate? Isn't it very difficult to control your mind? This was the question which Arjuna asked, that isn't it very difficult to control the mind? Minded that this is also mathematics, because Arjuna was onto a very difficult task and Krishna was constantly motivating him, and until he is focused he cannot do that. So the line what Lord Krishna told is that asamshayam mahabaho. Asamshayam means no doubt. There is no samshay, right? Asamshayam mahabaho mano durnigraham chalam abhyasena tu kaunteya vairagyena cha grijyate. No doubt, O Arjuna, Mahabaho is Arjuna, right? Who has got great bahu, that is hands. Asamshayam, that means, O Arjuna, the great Mahabaho, no doubt mind is difficult to control. Mano durnigraham chalam. Man is very durnigraha, that is very difficult to tame or to control. Abhyasena tu kaunteya vairagyena chega. Abhyas, that is practice, practice, practice. The other name of yoga, if you have read Sanskrit, it is called practice. Abhyasena tu kaunteya vairagyena cha grijyate. Vairagya means to give off everything, to digitally disconnect, right? And concentrate on study, mathematics or whatever. So the key factor of this mantra is what? Abhyas. Practice, practice and practice. It is only through practice that, O Arjuna, you will gain the vairagya, that is digitally or otherwise disconnecting and putting mind into your study, focusing. Then only you will get success, then only you will learn mathematics, then only you will be able to get a great career in mathematics, and the anxiety will be removed and everything will have a clear shape and you will fall in love with mathematics. So that's all for today. I think that I have been able to give you all those points, 10 important points which you follow. Click on the bell icon and subscribe. Click on the bell icon to get all the notification from Physics for Students. And do let me know if you have any other views to share with me. I will definitely put up in the next video, and I can take up your name and put it up as a constructive suggestion to improving mathematical skills. That's all for all of you. Wishing you all the best in your future endeavor and wishing you a great career in mathematics. This is Shaunak signing off, wishing you a great career and a great weekend ahead. Bye and take care.
Now You can be a part of our team. You can send your scientific articles, essays, research papers, lesson plans on a particular subject of science. For further details, please write to us at editor@physicsforstudents.com. Stay safe and happy.